We've spent the last decade building a cloud that is anything but ethereal. It's made of concrete, millions of gallons of water, and enough electricity to power small nations. On Earth, AI is hitting a wall. Power grids are buckling, and the cooling costs of the new GPU clusters, the H100s and the B200s, are becoming an environmental and economic nightmare. But as of January 11th, 2026, the solution is no longer on the ground. When Axiom Space successfully deployed its first 2 orbital data center ODC nodes, the conversation shifted. We aren't just sending data to space anymore. We're sending the brain itself. Today, we're going into the forensic details of why SpaceX, Amazon, and the ESA are betting $39 billion on a future where the cloud actually lives in the clouds. Why space? It sounds expensive, right? But let's look at the first principles math. Solar efficiency. On Earth, we have night, weather, and an atmosphere that scatters light. In low Earth orbit LEO, solar panels are up to 8x more productive. You have near continuous, high-intensity energy. The cooling paradox. This is the forensic detail everyone gets wrong. Space is cold, they say. Technically, yes, but space is a vacuum. You can't use a fan because there's no air to move. Radiative heat rejection. To cool a 2026-era GPU in orbit, you need massive radiator wings. We're moving away from simple passive cooling to mechanical pumped fluid loops MPFL and graphene-based thermal interfaces. SpaceX's Starlink V3 is the game changer here, with 1 Tbps edible viable to 1 BS, the full thing freeze with a 1 strap. It processes they are building a mesh network that doesn't just pass signals, it processes them. What affects is them? Portfolio. La file author. We cerdag just up needed to Florida. We evitam. This word that appliance into action. Dealing Samoth and Norcross Bowl at answer. Why do we need the compute there? Why not just send the raw data back down? Data triage. A high-res Earth observation satellite generates terabytes of data per hour. Bandwidth is the bottleneck. If an ODC node can run a Gemma or Llama model in situ, it can identify a wildfire in milliseconds and send a 1 kilobyte alert instead of 10 gigabytes of raw footage. Sovereign clouds. If you're a government that doesn't want your sensitive data passing through foreign cables, an orbital data center under your direct encryption is the ultimate black box. The AGI flywheel. Elon Musk has stated that terrestrial grids can't scale to AGI without hardship on the environment. Space-based compute is the only way to scale the trillion parameter models of 2030 without draining our lakes for cooling. It's not all sunshine and solar panels. There are forensic-level hurdles that could kill this industry in its cradle. The bit flip problem. Space is a shooting gallery of high-energy particles. We've seen HPE's experiments on the ISS. SADs fail. RAM gets corrupted. To survive, 2026 tech uses radiation-hardened rad-hard processors and software-defined fault tolerance. The debris crisis. Launching 1 million satellites for compute increases the risk of the Kessler syndrome. If a data center gets hit by a fleck of paint at 17,000 miles per hour, your cloud becomes a cloud of shrapnel. Legal flags of convenience. If a data center is orbiting over 190 countries a day, whose laws apply? GDPR. The U.S. Cloud Act. We are entering a wild west of digital jurisdiction. By 2030, we expect to see 5 gigawatt orbital arrays, structures 4 kilometers wide, dedicated solely to AI inference. We are moving toward a world where the internet isn't something we connect to on Earth, but a shell of intelligence surrounding the entire planet. The infrastructure pivot of 2026 will be remembered as the moment we stopped looking at space as a destination and started looking at it as a utility. The orbital edge is more than just a tech trend. It's a fundamental shift in how human intelligence scales. If you want to keep track of this transition and the specific missions like StarCloud 2 launching this October, you need to be ahead of the curve. Subscribe to the channel as we continue our Agentic 2030 Inches series. Join the newsletter, link in the description for the deep dive white paper on radiative heat management in LEO. Comment below. If you could host your data anywhere in the solar system to keep it off-grid, where would you put it? I'm AI and Tech Future, and the future is looking a lot higher than we thought. See you in the next one.